Here's the problem. So what we're talking about is this case, d over dx e to the power x is equal to e to the power x times natural log of e. What is natural log of e? Natural log of e is equal to 1. So now you know that this is equal to e to the power x. So we basically came from here to there, and then we obtained this equation from that. I mean, we knew it before, right? E to the power, actually, e to the power x. And then also from the next equation, we learned that d over dx log b of x, right? Base b x equal to 1 over x times natural log of b. So when you replace b with e, right? If you put d over dx log e x, log e s means natural log, ln, right? This is d over dx natural log of x. It is equal to 1 over x natural log of e. Natural log of e is again 1, so it's 1 over x. So this lesson we learned this one as well, and then this equation also. So all we have to do is to apply these equations in our problems. I think I did a couple of examples, and let's do some more. Let's see, 9, 12. So if I do problem number 12, right, it says find the derivative of y equals natural log of x cubed, right? Now we can use chain rule. We can use chain rule here, putting this u, and I can write dy over dx equals d over du natural log of u times d over dx u. Okay, I saw a lot of sometimes that you don't use this d over dx or d over du, but I strongly encourage you to use it, because sometimes I saw that without using that you may get confused with the parentheses, and then you get the answer wrong. So this is 1 over u times d over dx, again natural log of x cubed. Okay, and then you can let this is v as v, and then you get 1 over u times d over dv, right? D over dv, v, sorry, yeah, v to the power 3, v cube times d over dx v. It's 1 over u. The derivative of this is 3 times v squared times d over dx natural log of x. Now you can use 1 over u. You can put 3v squared over u times 1 over x. So u is natural log of cube. So you can put natural log of x cube. 3 times v squared, v is natural log of x, right? So it's natural log of x to the power cube. That is 1 over x. Right? So you have 3 divided by natural log of x times natural log of x. Because this cancel to this. Actually, this 1 and then natural log of x remains in the denominator. Does that make sense? This is number, oh yeah, 40. I'm sorry. Yes. Okay. And see. Let's do 23. Hope that I might have enough space here. So 23 to find d over dt log 3 sin t. So what should I do? It's all this one. What is the technique? What techniques can be applied? Yes, chain rule. How do you find the chain rule? How do you use the chain rule? What function do you describe as? Sin t. Very good. So you take this one as u, and then you can write d over dt u, right? And then you can use the chain rule d over du. So du times du over dt. Right? So from the equation that we learned, d over dx log bx is equal to 1 over x ln b. So in this case, it's u. So 1 over u ln 3. Log of 3. Right? Times d over dt sin t. So what is d over dt sin t? Cosine t. We can write cosine t, very good. U is sin t, and then natural log of 3. Cosine t over sin t. What is that? Cotangent t. Very good. Cotangent t. natural log of 3 is just number, right? So that's the answer. And this is from 3.9. Okay, they're working on 3.9. Then if I look at 56, because we learned before that, I would like to go to um, something related to exponential function. Let's try this. Let's try 20. What was that? 36. Log. Okay, let's try 29. It's in the list. 29. So 29, we need to find the derivative and then find the equation of tangent line at the point indicated. But if you find the derivative, that's enough. Okay. F of x equal 5 to the power x squared minus 2x. And how do I find f prime of x? Can you try this? Try to use what we have used, what we have learned so far. Any answer? Yeah. Now, move to the power 5, you can do this. But when you have 5 to the power you know, right, there's an equation. Oh, right. If I use well, because if not x, now this is the function. Then it has function. If it were just x, then you can. But now it's different. So make it suitable for a given equation, right? Then use that equation to solve that part. And next, look at the next part. Go like that. I actually explained that in the video as well. Actually, I just reminded before what we did. So these are the things that you need to actually remember. This equation we learned, right? This one. Okay. This equation. It's like 5 to the power u when you have a du here. And you got to remember these two equations. Or for the exam, I think you can bring an equation sheet. That's no problem. If you want to write all the equations, and you can bring it that way. And answer the questions. Okay, so how do we solve this? D over dx d over dx f of x or f prime of x is equal to d over dx 5 to the power x squared minus 2x. So we can apply chain rule. So which function you take as u? X squared minus 2x. Very good. So you can put that as u. Then you can write d over du 5 to the power u times d over dx x squared minus 2x. That's u. Right? So for the 5 to the power u, you can write 5 times, right? U is again x squared minus, sorry, 5 to the power, you can use this equation, b to the power x times natural log of b. So you can write 5 to the power u times natural log of 5. Right? Times, what about this? you can use the summation rule, d over dx, x squared minus d over dx, 2x. And here, 5u times natural log of 5, and this is 2x minus 2. Right? So that's the answer. You can take 2 out if you want, and then you can substitute for u. So 2 natural log of 5, right, times 5 to the power x squared minus 2x, right, times x minus 1. Like what Bryson asked me when I was going around is that whether we can do this in one shot. Yes, but be careful when you're doing it. Right? We can solve this in one shot. So how do you do it? Is if you're pretty good at doing this, you can do it d over dx 5 to the power x squared minus 2x as directly taking 5 to the power x squared minus 2x times natural log of 5 times d over dx x squared minus 2x. But I don't advise you doing this because use chain rule. That way you don't get confused. Okay, you can do that as well, but it's not encouraged. That's problem 29. And there are many problems like that in the problem set. And then I would like to work on 37. 37 is from the logarithmic differentiation. Remember, I talked about that in the video, logarithmic differentiation. So what we do is, let's say 37, find the derivative using logarithmic differentiation as in example 5. So example 5 is in the book. I went through that as well. So problem 37, you have several methods to find the derivative of this. You can find it in any way, any method, but this is a technique that can be used to find the derivatives of complex problems or complex functions. Now you can use the product rule, of course, right? You can use the product rule. But here what we're going to do is the logarithmic differentiation. So what we do is we take the logarithmic of both sides. Natural log of y equals natural log of x to the power 5, x plus 5 times x plus 9. So natural log of y, leave it there, and then this is a product, and we can write the summation of logs. The product can be written as summation. It's a log rule. Natural log of x to the power 5 plus natural log of x9, x plus 5 plus natural log of x plus 9. And this is equal to natural log of y. And now we get the derivative. D over dx natural log of y equals d over dx natural log of x plus 5 plus natural log of x plus 9. So this is d over dx natural log of y. What do you do for this one? What can we do for that one? When we did implicit differentiation, what did we do? To find the derivative of function of y in terms of x, what did we do? What is the technique that we did? We did this in implicit differentiation. Sum rule. Yes, we can do sum rule for the right hand side. What about the left hand side? What do you do for the left hand side? How do I find d? I need to find dy over dx, right? Huh? Zero. Which side? Why is that? Why? I didn't get you. So why to what? Oh. So supposed to no, we are trying to find dy. Right. So I have now d over dx natural log of y. So how do I find dy over dx from that side? What did we do in implicit differentiation? We had functions, a lot of functions, y equals something. And then we went from there to find dy over dx. Whenever we see something y d over dx y, what did we do? What did we do? What did we do in that case? Whenever we see d over dx y, how did we solve that? We use a rule that we have been using a lot. What is that rule? Chain rule. Yes. So what did we do is we put d over dy times natural log of y, and then you put dy over dx. This is a chain rule. This is how you apply chain rule. Okay. It's like when you have d over dx, some function of, f of u, where u is a function of x. Here you have f of y, where y is a function of x. Now, then the right hand side, d over dx, natural log of x plus 5 plus d over dx, natural log of x plus 9. Sum rule. Now d over dy natural log of y. What is the derivative? How do you solve that part? What do you write for that? What is d over dx natural log of x? 1 over x. So what is d over dy natural log of y? 1 over y. And that's equal to dy times dy dx equal to. Now you have x plus 5, right? X plus 5. So what do you do for that? You can define this as what? U. And this as V. Apply chain rule, right? D over d u natural log of u times du over dx plus d over dx natural log of v times dv over dx. Right? So what do I have here? 1 over u times du over dx is what? What is du over dx? When u is equal to x plus 5. 1, because d over dx x is 1, d over dx 5 is 0. So just 1. Very good. So this is 1 plus 0 plus d over dv, right? This should be v. D over dv natural log of v is 1 over v, and d over dx v is d over dx x plus 9 is equal to 1 plus 0. Right? So what we get? We get 1 over u, that means 1 over x plus 5 plus 1 over x plus 9. Now what is y? Y is y 1 over y dy over dx equals x plus 5 plus x plus 9. 1 over x plus 5 plus 1 over x plus 9, sorry. And then dy over dx is equal to what? X plus 5, 1 over x plus 9 times y, because I can multiply with this y. Y is x plus 5 times x plus 9. You can further solve this. See what the answer is. So you solve this as taking as a common denominator x plus 5, x plus 9. This is x plus 9 plus x plus 5, right? And then everything is multiplied by x plus 5 times x plus 9. This cancel that. Then what you have is 2x plus 14. So you could have actually used just the product rule and get the same answer, right? If I use the product rule for this problem, what do I get? I use the product rule. How do I use the product rule for this one? D over d xy equals d over dx x plus 5 times x plus 9. Then I can use the product rule. X plus 5 times d over dx x plus 9 plus x plus 9 times d over dx x plus 5. So you get here x plus 5, right? From here, what do you get? D over dx x plus 9. What is the answer for that one? That's 1, right? 1, right? Plus x plus 9. And you get 1 for d over dx x plus 5. So you have 2x plus 14. In this kind of problem, this is not very useful. But whenever you have a complex problem, complex problem, which means problem like this. We look at that. 43. Look at 43. 43. Y, or let's take f of x. F of x equal square root of x times x plus 2 divided by 2x plus 1 times 3x plus 2. 2x plus 1 times 3x plus 2. Now, this is a complicated thing, right? This has a lot of terms, right? So in this case, what we learned before is useful, right? Now, how do I use this? I'm trying to write, I'm going to write this as x to the power half, x plus 2 to the power half, divided by 2x plus 1 to the power half times 3x plus 2 to the power half. Sorry. Or you can put everything to the power half, right? Let's put it that way. Let's put it. It's not thinking to convert it to. So the square root is actually half power. So I can put it's like this. Now, what is the next step for the logarithmic differentiation? Take the natural log of both sides. We take natural log of f of x and the natural log of this thing. Right. Now take the derivative. Okay. Now take the derivative. And when you take the derivative, you can write this as, right? When you have a power here as a log power, what you can do? What can you do? You have power of log. You can multiply with this one. So whenever we have something like this, natural log of x to the power p, you can write p times natural log of x. That's a log rule. Might have learned this in pre-calculus. And here what I can do is I can write half times natural log of x times x plus 2 over 2x plus 1, 3x plus 2. Now when you find the derivative, d over dx of x 2 3x plus 1, 3x plus 2. Good. Actually, it should be natural log. So I missed it. So d over dx half, something like that. Right? And then you can take the half out. And then you can find d over dx Now this has a division and also multiplication for natural log, right? So what can you do? When you have division, log of a division is equal to subtraction of logs. Okay, so you can write natural log of x times x plus 2 minus natural log of 2x plus 1 times 3x plus 2. Okay, now this division is written as a subtraction of logs. Right. For example, if you had log of x over y, you can write like that. Okay. And then we have multiplications, right? I did still find the derivative, right? So this is a multiplication right here, x times x plus 2, right? So I can write natural log of x plus natural log of x plus 2. And then you have a minus sign, and you can write this as a summation 2. Natural log of 2x plus 1. Now plus becomes minus because of this minus sign in front of it. And I can write that natural log of 3x plus 2. Right? Now, is it easier to find the derivative now? Is it easier? All the terms are in natural logs now. Right? So now it is easier. Right? Now it is easier. You have half. The first term is d over dx natural log of x plus d over dx natural log of x plus 2 minus d over dx natural log of 2x plus 1 minus d over dx natural log of 3x plus 2. Right? Now you have d over dx natural log of x is equal to 1 over x plus d over dx natural log of x plus 2 is equal to you can put 1 over x plus 2. Right. Now you get some kind of feeling about it, right? And then minus d over dx natural log of 2x plus 1 is equal to 1 over 2x plus 1 times what? The derivative of this function, right? Chain rule. The derivative of this function. What is the derivative of that function? What is the derivative of that function? 2, right? So you multiply that by 2. And then minus d over dx natural log of 3x plus 2 is equal to 1 over 3x plus 2 times the derivative of this function. 3. So you multiply that by 3. And close the parenthesis. While you're doing that part in that side, now it's all find the derivative, and you can actually simplify it by using algebra. Okay. And from this side, what do you get? D over dx natural log of f of x, right? According to the previous ones, all the functions what we did, what did we do? We 1 over f of x times what? F prime of x. That's all we did. But how do we get that? Can anybody suggest, well, how do you get that? What is the rule that we use? We use some rule implicitly. What is that rule? How do I get from here to here? What is the rule that we use? From here to here. Chain rule. You put f of x as u, then d over du, natural log of u, is equal to 1 over u. The 1 over u is f of x. 1 over f of x. Times du over dx is d over dx f of x, which is f prime of x. Right? Same thing we did here too. In these terms. Same thing. Right? So we can write this as f prime of x divided by f of x. Now, if you need to find f prime of x, then you have to multiply this by f of x over 2. Then you can write 1 over x plus 1 over x plus 2 minus 2 times 2x plus 1 minus 3 times 3x plus 2. Now you can simplify it. Multiplying with f of x, and then you can do whatever you want. Basically, we have solved the problem. If you want to do it with this complex equation, you might need to assign some of the functions as, u, and then you have to derivate, you have to use the quotient rule, product rule, and all sort of things. That makes sense. So this is the different way of find the derivative. That's called logarithmic differentiation. Logarithmic differentiation, right? I uploaded a video about that. I don't know if you got a chance to look at it. It's called logarithmic. Okay, let's work on problem number 64. Y is equal natural log of hyperbolic cotangent x. (64) y equals natural log of hyperbolic cotangent x. Now in this lesson we learned the we learned the derivatives of hyperbolic functions as well. So now I need to find d over dy dx, d over dx y. So what can we do to solve this problem? D over dx, natural log of hyperbolic cotangent. What rules can we use first? Can use chain rule? Yes, very good. D over du, natural log of u times d over du, sorry, d over dx u. Now u here is equal to hyperbolic cotangent x. Right? So this is 1 over u, d over du, natural log of u is equal to 1 over u. And then we have to find d over dx, hyperbolic cotangent x. Right? And hyperbolic cotangent x derivative is equal to what? Right. So this is what 1 over u is hyperbolic 1 over hyperbolic cotangent x times negative hyperbolic cosecant x squared, right? The negative sign is there, and cosecant x is cotangent hyperbolic cotangent sorry hyperbolic cosine sine x, right? Sinh minus this is 1 over. You can solve this probably. So they have this is 1 over. This is actually 1 over hyperbolic cosine x over hyperbolic sine x, right? Negative 1 over times negative 1 over hyperbolic sine x squared. Right. This is not sine, this is sinh. And I can move this sinh just to numerator. Sinh x divided by cos x. And the negative sign I moved here. And this is 1 over sinh square x. And then this becomes negative 1 over cos x times sinh x. You can bring an equation sheet on the exam. Next exam, I will have next exam on next Tuesday. I'm not going to be available on Monday in person, but I'm going to be here on Tuesday. We are not meeting here on Monday, but we'll be meeting on Tuesday. Is that fine? Does it make any difficulties to work schedule or something like that? Okay, let me know. Okay, if it does, I can move it to Thursday. Exam. I have some other commitment on Monday, so I will do online portion for next week on Monday. And I'm planning to come on Tuesday. If you have any difficulties with that one on Tuesday, let me know so that I can move the exam into Thursday. On Monday? Yes. Yes. What do you think about asynchronous classes? Do you watch videos or not? Okay. Just let me know. Yeah, okay. But I'm uploading all the videos. I'm recording these classes as well, and then upload there, and it is always available. Then go and watch there. And one other thing, is it okay if I move this homework to Saturday and quiz as well? And the quiz, I prepared a quiz for today, but since you didn't work on the homework, I don't want to give you the quiz today, but I will give us a take-home quiz on Saturday to finish both of them. Homework, and you do the homework and upload it, and then you open up the quiz. I set it up like that. When you after you upload, you get the quiz and do it.
So the homework is still on Sunday.
Saturday. Saturday, good. Okay. You have enough time because I worked out some of the problems right now, and you have a few more problems you can work out. Yes, Saturday this homework, but you don't have to work out the problems that we worked out in the class. Do the rest. We have all the numbers, right? We worked out. So cross it out and work the other stuff and then submit it. Right. And then we did 64. Pretty similar type of problems. You can 71. I can show you 71 pretty quickly. You just apply the chain rule and then use whatever the functions that you learned. This is 71. It's y equals e to the power hyperbolic cosine x cosine inverse. It's an inverse function, inverse x. So what we did previously was hyperbolic functions, now hyperbolic inverse functions. We had trig functions, inverse trig functions, hyperbolic functions, in hyperbolic inverse hyperbolic functions. We have log and exponential functions. It's feel like that we did a lot of stuff, but it's same thing over and over again. We'll be using some functions, some equations, some derivative things that we have actually obtained and derived. I don't want you to remember all these equations. This is not possible. So you can have your equations for these equations, and you can use those equations to solve the problem. But whenever you may realize that later, whenever you solve more and more problems, you tend to remember those equations automatically. In that case, that's fine. You can use that. But I don't necessarily want you to remember that within this short period of time. It's very difficult to remember that many equations. If you don't see the connection in between this, if you see the connection in between those, yeah, you can obviously derive those things, but deriving those things takes time, and that's not appropriate in the next section. So let's find this one. Dy over dx equals d over dx e to the power hyperbolic cosine inverse x. Same thing, right? What do you do? Chain rule. Again, chain rule, right? D over du e to the power u times du over dx. So u is hyperbolic inverse cosine x. This one, u. U is equal to hyperbolic cosine inverse x. And Now d over du, eu is just e to the power u, right? And d over dx, hyperbolic cosine inverse x. There's an equation in your book, hyperbolic cosine inverse x is equal to 1 over square root of x squared minus 1, which is true for all x greater than 1, right? So this is e to the power hyperbolic cosine inverse x times 1 over square root of x squared minus 1. That's the derivative of cos x. This is called cos. Cos, not cos. COS, cos is cosine. This is hyperbolic cosine cos. And sine function, we have hyperbolic sine function is called sinh. And hyperbolic tangent function is called tang or tang. I don't know how to name the other functions, so I call them hyperbolic cotangent, hyperbolic cosecant, and hyperbolic secant. So that's the answer for this one. So you can write it nicely. Right. Okay, so I'm going to finish up that problem discussion session with that, and we can have maybe 10-minute break and then come back and we'll start a new lesson.